So let's just wait maybe 2 more minutes for the others. All right, so let's wait another minute. Okay, so it's already 12:15. So going back here, I guess it's already here. So this is the easiest explanation. So if P or Q is true, so true, true, and P is false, okay, there's one right here. But again, then initially, whatever is the value, this one is also true. But if you're going to evaluate this true statement, it's saying that this true statement is negated P, or it is also true that this true is a false statement because coming from this one right here, it's already negated as negative P, or it's saying that this one is already a false statement. That is why it says here P is false. Okay. Then Q must be true. Why? Because again, in inferencing, everything must be true, or you have to come up with a conclusion which will make the entire statement as a true or as a tautology. Okay, so vice versa. So in here, it's proven that this Q is false. So that is why you have to write P, because this one is the only remaining true, or this will make the entire statement true. Okay. Well, anyway, let's move on to the other examples or other rules, which is, let's see, modus ponens. So this one, we have P and then P conditional Q. Okay, so in here, you can answer Q only, okay, because everything is proven as true, okay. So P is true, P is true, and then Q is true. It's just that you are implying or you are concluding that the entire statement can be concluded as Q, or whatever is the value of Q, okay, will make the entire statement true. Okay, so if this is false, okay, then this one must be false also, because it's saying that the P is already a false. Now, if we have false and then true, going back right here, if we have false and then true, wait a minute, why is this true? Let me just check this one. False and then true, and this one is also true. Yeah, it's correct. If we have false and then true, then this one is already true. But if we have the other way around, wherein, let's say we have true and then false, or false. I guess this is the only one that will make the statement false. And then the rest, so false, false is also true. False, true is true. And then true, true is also true. So the only thing that you guys need to keep in mind when it comes to conditional is this one. So true, false. If we have this one as true and then Q is false, then that will make the entire statement false. Okay, so that is why we have this one as, if we have a negated P, it's okay. So false and then true is still true. So nothing will change. So true, true, it's still true. Okay, but if Q is false, let's say you've written here negated F, well, actually, even though it's negated F, because F, false, false is also true. So I guess in modus ponens, whatever is a value, whatever is the one that you're going to negate, the first one or the second one, the hypothesis or the conclusion, that will still make the entire statement. Okay, so you can always answer Q whatever happening here. Okay, it's just that I guess it need more example when it comes to false, false. Okay, but in modus tollens, okay, so it's now the other way around. Okay, so we have P conditional Q is true, true. Okay, but then again, we have another statement right here or component right here, which is saying that Q is actually false. Okay, now in here by default, okay, so let's have this one true conditional true for this one, correct? Were you guys able to follow this one, this true and true coming from here? Because we assume everything is true in inference rule or rules of inferencing. Are we correct with this one? Anyone? Are you guys still around or no?
Yes, sir.
Because how will I proceed if I'm not talking to anyone? Anyway, again, we assume that P is true. That is right here, and then Q is true. Okay, but then again, there is another statement saying that Q is actually false. So from true, it will become false. Now we have true conditional false. If you guys are going to check this one right here, okay, if you're going to answer just Q, then you're seeing that this one is already false. Now you have to make, or you have to find an answer which will make this let's say parang final, your final solution to make this one as a true statement. Now our only last option is to make the this true right here to become false also. So from here, true false, just make that one false false. So you can just answer here negated P. So that is why negated P and then negated Q is now equal to true. Okay. That is for modus tollens, if I'm not mistaken. Yeah, modus tollens. And then modus ponens, your conclusion is always true. But for the modus tollens, it's the other way around. So your conclusion now is always false. That is why it's called modus tollens. Okay. So I guess in here, don't have a problem. You can answer Q or P. But in here, you have to negate that P, or if it's the other way around, say Q, just to make the entire statement. Okay, you have to come up with this true result. So any insights so far or any comments?
Wala, sir.
Hindi ko kasi makita yung reaction eh. Gusto ko sana, mas maganda to kapag face to face kasi nakikita ko yung parang, ha? Ibig sabihin, hindi nyo pa rin na-gets, diba? Like here right now, you're off cam, so I'm not seeing anything. So I don't know what to expect if you were able to get it. Are you getting this part? Are you getting this part? Are you okay with this part?
Yes,
So,
sir.
is it okay if you guys will open your camera? I guess that's no problem with Mr. Parda because it's always on cam with my previous class.
Can you see me, sir?
Ano yan?
Can you see me?
No, I cannot see you. Bakit?
My
Black?
cam's broken, I think.
Kala ko nag-open ka ng camera pero bakit dakpan mo lang saglit sabi mo. Anyway, baka nasira yung camera.
Sir, no, walang takip.
All right, what about you, Mr. Balboa? Don't worry, still have 2 hours or let's say 3 hours kasi hanggang 3:30 naman yung class niyo, di ba?
Kung di ko naintindihan, sir, tignan ko na lang sa ibang videos. I-repeat ko na yung binigay mo link.
Okay, again, ang pinaka-keyword nyo lang talaga is true eh. Dapat sa inferencing, dapat lahat true. Okay, or your conclusion should make the entire statement true. I guess that is the most defining term. Okay, so your conclusion make the entire statement. I guess best example for this one is the modus tollens. Okay, so why did we answer negated p? Because we wanted to make the entire statement true. So we have here true false. Again, if it's true false, then if you will answer p, that's still false. If you will just answer q, that's still false. Okay, so we have to answer here negated p because we wanted to negate your hypothesis, this one right here, from true. Just make it false for you to have a false, false, and then the entire statement now is true. Coming from here. Okay. So do we have more rules? I guess this is just a summary. Okay, so we have P and Q. We have this one. We have P and Q for conjunction. For modus ponens, we have let's say true, true. So if everything's true, then we can assume that Q is also true. Okay, well, actually, either of those, you can just answer P because this one is also true. And we also have here P conditional Q, which is now, you have to make this one negated because it was proven that this one is actually false. So false conditional false is actually true. So that is why we have here negated. Okay, and then the rest, this one is quite simple. Now, again, you can answer here just P or just Q. Either of those two will be correct. Okay, since true and true is true as a result. And for the disjunction, so here we have P conditional P or Q. In here, it's now quite intriguing since when it comes to, or if there is one statement that let's say Q is false or P is let's say false, then the entire statement will become false. So that is why we are like assuming that P is always true and then Q is always true. So that is why true or true is true. Okay, that is for this example. So vice versa. Okay, so Q conditional P or Q. So P must be true and then Q must be true also. Okay, make this one part of the inferencing rule. So all of them will make the entire statement true. Okay, so I guess the only example right here, which is quite confusing, is the disjunction, and then the others are very straightforward. Anyway, more examples, right, or rules, another rules which is not mentioned here. So in here, I have only one explanation regarding with this one because this one is actually quite hard to explain before. So what I mentioned to my previous class is once you saw something like this, P conditional Q, Q conditional R, and then you're like seeing, the variable right here is the same as one, we can assume that P conditional R. Okay, so there is no other examples that I can think of aside from truth table. Okay, it's just that you have to memorize this one as it is. Okay, hypothetical syllogism. So P conditional Q, Q conditional R. If you saw this one, you can assume that it's P conditional R. So it's like, having a shortcut. Okay, So that's what I mentioned, if not mistaken, in my previous video, in my compiled Zoom meeting. Okay, and this one right here, this one is disjunctive, so I'll use more elimination. So in here, negated P is P or Q, right? This is a good example for disjunctive, or why it's called elimination. Okay, let me just remove this one. Again, in rules of inferencing or inferencing, your result, your conclusion should make the entire statement true, right? But in here, as you guys can see, this is the first statement, first row, P or Q. So we assume that it's true or true. But in second row, it is saying that P is actually false. False or true. Now, if you're going to evaluate this one, this is already false, right? Am I correct? Going from our truth table of the OR. Tama. Mr. Balboa, Fardo, Alexi Domayan, Lazaro, are you guys still around?
Yes,
Unless
sir.
Yeah,
yung sabihin kailangan pa natin bumalik sa truth table ng OR. This one.
We know,
Here,
sir.
OR. Okay, so if there
Goods
is
na, sir. Goods na.
okay. Kasi walang sumasagot eh. Para mabilis tayo. Okay. So in here, if you're just going to answer P or Q, okay, then oh, wait a minute. So in here, it was proven that P is false, right? So you don't, or you must not answer P as your conclusion because it's already proven as false. So that is where the name elimination will be coming from, instead of or reducing that one into a smaller component or smaller statements. So you have to eliminate the false one, wherein in here we have eliminated the P, okay, just to make the entire statement true. Okay, so we eliminated this one, it's false. So the only remaining variable now is Q. So that's why we have answered Q. Okay, so that's why it's not P, but it is Q. So the same with this one. So it's the other way around, wherein Q now is the one that is proven as false. So again, initially, this one is true, but was proven that this key is actually false. So we have to eliminate this false now. So that is why we have our answers. Okay. So again, your conclusion should make the entire statement true. Okay. So this one is super applicable with mod tolerance, and then the same with this one, disjunctive syllogism. So you have to eliminate the false one for this one and then retain the true one. So medyo clear na ba? 10%? How many percent?
yes sir, nagigets na.
Nagigets na. Okay. So I hope medyo nagigets mo na rin, Mr. Balboa. Well, we'll still have a meeting tomorrow, or we can have another meeting tomorrow if you want. So this is just for those who has a question, okay, or a clarification. So if you don't have a question or clarification, then I guess no need anymore. But before that, before I will announce that we'll have a meeting, so just message me first. So this is also for those who are not here right now. If you guys will be able to watch the Zoom meeting, then just message me. And then if a lot of you has a questions or clarification with that topic, then I will have another meeting tomorrow. But if we can solve that one via chat, then I guess no need anymore. Okay. All right, so the last one is contradiction. So we have here negated P, conditional false. So you have to make this one. Again, this one is also quite confusing at first. But then again, we assume that everything is true. This entire statement is true, conditional false. So that is why sometimes you have to skip this negated, whatever is that one. We don't care what is the value of this negated p. It's just one component. So in here, it is saying that we have true or false. Okay. So in order for you to make the entire statement true, you have to negate this one. Okay. So you have to make this one false, because false, conditional false, is equal to true. This one right here. So that is why we have answered here P, okay, not a negated P or whatsoever. Okay. So the same with, say, well, let's just say this is just another variable. It's just that. Okay, so in here you have to answer Q. Okay, because false, conditional false is equal to true. Okay, so again, we don't say that this one is already false. Well, if you'll see that this one is already false, conditional false, then of course you will just answer false, right? But that is not the case. So that is why we have to assume everything is true at first. Okay, and then evaluate on the second part. Where in here we have evaluated that this one is actually true, and then we have to make this one false to make the entire statement true. All right. So, and then here are some examples, just to prove that this one is actually a tautology. Okay. And then in here, I just have to prove that, what are the rules of inferencing that you're going to use or you're going to apply in order for you to prove that this statement right here is equal to negated. Okay. So in here, the applied contrapositive and then modus ponens. And then in here, so it wasn't mentioned anymore on what we have used, but I think this one is the conditional. This one is this one right here. I forgot the name. Conditional ba yun? Here, I think eliminate. This one right here. Maybe modus ponens or modus tollens. Well, either of those two. Okay, which one is fitting with this example? Wala bang... Okay, so let's have one example. This one right here. On how did they arrive with this negated x and then x or negated s. So it started with this one. So u or negated x. So it was proven that this one. So I guess it would be easier if we'll just write here the value. So true or say false na lang. Okay. Let's just evaluate this one as quick as it is. Okay. So in here it was my apologies, true. Okay. So in here it was proven that the second row, okay, it was proven that this one is actually false. So we have to apply elimination. Okay, so just eliminate that one and then retain the true one, which is the negated x. Okay, and then moving to the next one, what we did here is why did it retain? It just copied. Okay, so it's still the same x or negated s, still the same from here. This was just copied from here. And then here, the next step is negated x. So in here, it was proven that x is negative or false. Okay, then we have to retain the true one, which is the negated s, because again, we assume all the components or variables are true at first. Okay, so negated s, copy pa rin. So just copy it and then R conditional S. So in here, it was proven that this one is false. Okay, then we have to make this one false also. So initially, of course, this one is true, but we have to make this one false to make this one as, still true or tautology. So false conditional false is true, or you have to make this one negated or negative. That is why we have here negated part. Okay, we just made this one from true to false. And then the last one, okay, P conditional R. So this one is initially true, but concluded as false. Okay, so this one is true conditional false. And again, true conditional false from our conditional truth table is false. So you have to make this one false to make the entire statement or this statement true. So that is why we have here negated. So thus, we were now able to prove that those statements is just concluded or can be reduced into negated P, or this one. So we applied or elimination, and then modus tollens, and then another modus tollens. Yeah, for 1, 2, 3, 4. Yeah. Anyway, so I hope we're clear with this number 3. So were you guys able to follow on why did we come up with these solutions?
Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So again, don't get confused by this negative, negated. So again, we assume that this statement or whatever is the value of this one is always true. So that is why it's mentioned here, or the answer here is a negative x, not x. Okay. So just practice more for you to familiarize this rules of inferencing. Anyway, so do you guys have any other concerns or questions?
None, sir.
All
Wala
right.
po. Wala po, sir.
So I guess that's it before your midterm exam. So again, if need something, if you have a question, so don't be shy to ask. Okay, I'm just here for you guys to be guided. All right, so yeah, that's it. So I'm pretty sure that most of you are hungry right now, or probably some of you are already eating. So goodbye, and thank you guys for coming as always, and happy lunch, and then keep safe.
Thank you, sir.
Thank you, sir.
Thank you too, and goodbye.
Bye, sir.
Goodbye.